right. So, hello everybody. First of all, I have to excuse myself. Maybe you realize it. I have a very sick voice today. So if you don't really understand what I'm saying, it's not German. Just it's like, just raise your hand if you have troubles understanding me. I will try my best so you can understand me. Second of all, I promised you to talk about an introduction about reason. But because of my sickness, it was kind of hard to do this like live coding session thing, and I was thinking about like making a related topic, which I've been talking about a lot, and I hope you will enjoy it. Okay, so we will have the first trouble? No, it works. Okay, so thanks to our sponsors, of course. I'm going to talk about the road to a statically typed future. And maybe you realize this little flag there. This is the Austrian flag. I'm also part of the React Vienna organization team, and we do a lot of stuff. So maybe you have talked to some Viennese people here. Really great to be here. And before I even start off, like the idea of this whole talk, generally speaking, if you go to a talk and you listen to some speaker, I urge you to be critical about what this speaker is talking about, because every speaker comes with a different context. Like everyone has a different history, a different idea, and the different solutions they want to create, right? So I just give you a little bit of context, what I believe is like my ideal. So first of all, I started off as a Java developer, and I was used to be like to be writing code in an IDE, and just using like the auto-completion features, the auto-generating features. For me, Java was kind of nice, and I never questioned the status quo. I was always like, okay, this is kind of nice. Then I was introduced into Java Enterprise, and I was introduced into Spring Framework, then I was introduced into SOAP interfaces, and then I got a little bit itchy. You know, it's kind of like there has to be a simpler solution to create little projects. And I was fortunate enough, like in 2012 or 2011, maybe you realized that there was this little thing coming up. Someone made this crazy idea bringing JavaScript to the back end. And that's the moment where I realized, okay, this might be an interesting technology to invest in. And the company also supported me in using this technology. So I've been using Node.js since, I don't know, 4 years, 5 years now. And it was a really, really great experience. I was coming from like, you know, aesthetically typed, strongly bound to an IDE language, and I could not just create things. I could not just like try out things. It was really hard. And in JavaScript, it was the other way around. Suddenly I could like manipulate every object. I could just strip away the object prototype if I wanted to. And it was great. It was a really, really nice playground to have experimentation in. Later on, like in the end of 2015, I was introduced in another company, which is called Runtastic. And what they did is they wanted to introduce React Native in their existing fitness applications. So they wanted to have a new news feed. So if you go to the Runtastic app and you see the news feed, this is actually what I was working on. So I tried to introduce a JavaScript stack into a mobile application. And this sounds very ambitious, because this was in a time where React Native was just released. So this was also very risky. And you can imagine how hard it was like to tell a mobile developer, like iOS developer, Android developer, that JavaScript will be in their application. They're like, why? I mean, we can write this more efficiently in our language, right? And of course, you need to be able to build an application which is so stable that it will not crash your application. I don't know how many people know React Native, but React Native runs in a main thread, like the JavaScript code runs in a main thread. And if the main thread crashes through a typing error or through, I don't know, some unresolved promise, your whole application will crash and you will land on a home screen. So you can imagine it's a very tough choice, like, okay, you have this social problem, like you have to introduce this technology and you need to make sure that this doesn't crash for the user. So I was investigating some time, like how can I make this very highly dynamical code more maintainable? Because every time we had a change, it was very hard to understand what implications each change has. And Forbes has been talking about it today, like the testing pyramid, right? So statically typed code should be like the foundation of everything. Before you even run the code, you should know if there is an error in there. And yeah, Flow, luckily enough, Flow was introduced like also in that time, like it was open sourced. And they promised that they have first level support for React. So this was perfect. I was like, okay, cool, static type system. And it's kind of like a little bit nicer than Java. We'll go into that later. And it's also React compatible. So I've been working with Flow for approximately 2 years now. And maybe if you know me, if you have been following me on Twitter, I've been writing a lot about Flow. I've been evangelizing a lot about it. And I've been doing a lot of talks. So you can also find it on YouTube if you want. It's a very interesting technology. But what for me, like the whole outline of this talk is what can I imagine could be like the future for me, like how can I make my stack, what I have right now, even better? So I'm just trying to improve for myself and also try to improve for my colleagues because my colleagues need to maintain my code. And the current project I'm working on is called Lagoon. It's an open source project, so I'm privileged to say that I work full-time on an open source project professionally. It's maintained by Mazy.io. They're a DevOps company. So what I'm mostly doing is more like DevOps related stuff. And this specific project is all about Docker deployments. So what they do is they take your Docker Compose file and replicate the behavior of the Docker Compose in your production environment in OpenShift. And apparently there is no solution for that right now. So they built it, and now they open sourced it, so you can look into that if you're interested in like having a Docker Compose, which is also the same behavior as in production. And why is this important? We use a lot of Node.js services in there, and of course we're using GraphQL. So I was really hyped about the GraphQL talk today. Yeah, and this stuff needs to be typed because if you have microservices, you need to define some kind of interfaces. You need to define some data structures you are handling in between the microservices. And if you change any of these types in between, you have no idea because you need whole integration test environments which test exactly this feature, if this change will break anything. I mean, you need to have integration tests and end-to-end tests, but I still feel very, very uncomfortable making small changes to data types or data structures. All right, so this is my foundation. This is where I'm coming from. Now I want to talk a little bit what is a type system, because not everyone has been using type systems forever, not everyone has been using Java. So a type system is an extension to the syntax of JavaScript. There are, like, we also heard it today, like TypeScript and Flow, for instance. They just extend your syntax with certain type attributes. So you can define a function which gets a parameter and has a return type. So here in this example, we just say we get a which is a number, and the return type is a string. So what does the type checker do? The type checker takes the code, creates an AST, an abstract syntax tree. What is this? It's basically just a data structure of your code. It's like tokenized, and then you can explore it. There is a tool called AST Explorer. You can just insert some code snippet in there, and you will see the AST as a node structure, as a tree structure. You can just analyze it. And the most important part about a type system is a nice working remote. The analysis. So the analysis engine, the algorithm behind it, and that's the major difference between TypeScript and Flow when people were discussing what is the difference actually. Because not all types are equal. And let's say, what a lot of people do is like they have two technologies and they say, okay, let's make a checklist, right? Because that's the easiest to get to the project manager or whoever, or like the tech lead. So maybe types. Do they have maybe types like nullable values? Yes, both of them have nullable values. Do they have generics with the angle brackets? Yes, they have generics as well. Do they have covariants with read-only and write-only attributes? Yes. I'm not sure about TypeScript, but in Flow it's definitely there. Subtyping, extending classes, and understanding the inheritance hierarchy. Yeah, both do that. And inference is like the thing where the type system can guess the type of a certain value. For instance, if you're assigning a variable and you assign a string, you don't have to explicitly say, this is a string now, and then you assign a string. Very similar to how C or Java or whatever works. Maybe you know that. We don't need that. Type inference will take this off. So this is very, very nice. And for me, the quality of this type inference is the most important part. So let's talk a little bit about that. Reliable type inference will influence the way you write code. That's my exclamation, so if you want to cite that, anyways. It's easier to cite yourself, but anyways. Let's see, like a simple example, TypeScript. If you have a callback function, you just make a function which gets a value which is a number and it increments it by 1. In TypeScript, you are required to annotate the input parameter. There is no way you can just leave it out. It's just required. For the return type, it's okay, because TypeScript is clever enough to figure that out, but for the input, it's not. So now we can use an array with 1, 2, 3, unless you're using the no semicolon way, then it will break, but that's a joke, yeah, I don't know. So if you use map increment, it will realize 1, 2, 3 is a number, so this will type check. So we'll have no errors. If you try to input a string in there, in this array, TypeScript will shout at you that this is not right. So this is good. Let's look at flow. So here, the major difference is I don't have to annotate the input parameter. Why is that? Flow, the name flow comes from the algorithm. So what they do is like they analyze the flow of your program and try to refine the types as they get in, like as they flow through your application. Like if you assign a variable, if you're using plus operator and stuff like this. So it tries to kind of like intelligently guess the type you want to use. So here, it will just assume, okay, first of all, we have a plus sign in there. So in the beginning, it will say, okay, this might be a number or a string, which will be returned or which will be input. And it can also make assumptions through the code. Like if it sees as an array with only numbers in there, then this might be a number. So this is like the thing which I really like about Flow. Why is that? Because I use a lot of functional patterns. And maybe you have seen some code examples today with a compose function, for instance. So what is a compose function? Let's say we have three functions called increment 1, 2, and 3. So they just increment 1, the other one increments 2, and the other one increments 3. And we want to compose it into a bigger function or a more convenient function, which is called increment 6. So now we have this function called increment 6, so we want to increment 2 by 6. So how does this look like? So we have a chain of functions with an input value and an output value. If you put in 2, it increments 1, so the output is 3. The output will be piped as an input to the next function, which will increment 2, so it's 5. The output will put into the next function, and we get 8. Okay, that's simple. That's a very simple example, very trivial. So how does this look like in Lagoon, for instance? We have an API where we want to query the host string of a specific customer, like he or she deployed some server and they have a URL or something. And we need to gather this data from our customer database. So we have this huge function. Don't get scared by that. I know it's kind of like really weird to read. First of all, compose reads from the bottom to the top. And second of all, we just use like these names. We just say, for instance, we put in an object, so we call this whole function chain. We pick out 2 attributes, which are server identifier and server infrastructure, so we get a new object out with these 2 attributes, which will be piped into the values function, which is then just getting the values out of this in an array, and then there is an if-else constellation. So you get the idea. This is kind of like Lisp in JavaScript, but actually not. It's like more verbose. So I would prefer Lisp to that, but well, you cannot have everything, right? So you can imagine that this is very hard to type because you always have to like define all the input parameters and output parameters, and then we end up in a Java-esque way where we have to write a lot of boilerplate, a lot of type code, and it doesn't make any sense to experiment. Also for React, it's well noted that like Flow and TypeScript, they can both understand JSX, and they can also understand like pure functional components, for instance. So it gets a props object which has a shape of user with a string, and yeah, we can use that here in our JSX. Reliable type inference will motivate experimentation changes. That's the major point why I like inference. I mean, sometimes you get very cryptic error messages, I know, but at the same way, I can freely move in my code base. I can try out things. I don't have to worry about like annotating everything. I can still be type safe, also like in Java, for instance, but I don't have to write a lot of boilerplate code. So it's really, really nice to be able to use the dynamic attributes. But there are a few trust killers when you're using Flow. So the worst of them all is the anytype. So the anytype is not really a type. It's more like a placeholder. As I said, the types flow into the next types. So any is kind of like the universal placeholder for everything. There is no type checking involved when you're using any. Then there's the object type. The object type is a little bit better. You know, it's like nice facade, but you still don't know what's in there. It's a map of key value pairs, but you don't know which attributes are in there. Are they nullable? Are they not nullable? Are they undefined? Whatever. I don't know. And the third of them is the function, which nukes the type out of your code base because you have an input parameter and an output parameter, and both of them are any. So this is very bad. And this is what I have with Lambda. Like I have to anytype a lot of inline Lambda functions, and then I don't know if these compose change are actually well typed. So sometimes we use this like here. So we have a test function maybe, and we don't care about the shape of the object because it's a test, and we just annotate it with any and don't care. Or maybe you have typecasting. So sometimes you get data from a REST endpoint, and you're like, oh, I know this is the right shape, and I just typecast it. So it looks like this. You take the object, cast it to any. So it's a placeholder, and then you can safely cast it to, like you can cast it, not safe, but you can cast it to a string, and Flow will understand, okay, this is now a string. And from there on, it's kind of like working with this contract. So in a more abstract point of view, we have type 1, type 2, input, output. We have the chain. And if we put an any anywhere in this chain, suddenly all the output values and the input values are any as well, if you don't annotate the functions explicitly. So this is a problem. I would like to use the type inference without worrying about the any. That's one of the things. Also, like if you think about a module, if you have a library, you have a lot of functions in a module which expose a lot of any types because you don't know how to type them, because most of the libraries are designed in a dynamic way. A lot of libraries cannot be typed because of their very dynamic nature. Okay, so now we get this out of the way and just think about an application. So we have an application. How does the application look like? How should we design an application when we have types in mind? So my recommendation is usually start with the model types. Think about your domain model. Think about how does your user objects look like? How does your project tuple look like? I don't know. What kind of data structures you're handling? Because this is what the developers are most afraid about. Like, oh, I need to be specific now. I don't want that. I just want to drop it in MongoDB and don't care about it. That's what a lot of people think. I changed my mind about MongoDB. I was like, I actually would like to use Postgres or some schema-full SQL because it's very, very good documentation and you cannot do any mistakes. It's tedious to insert test data, yes, but your application will get more stable. And around this model types, we built the business logic and we built UI components. And as I said, with the pure functional components, you get the props. You can still use these model types. The model types are in the type space. They are not getting inserted in your code. So you're not shipping the type information. It's stripped away during the Flow's compile time. Or if you're using Babel, you just strip away the type information. So what you ship is only JavaScript. And that's also very important. So this, if you design an application like this, it's kind of like interlocked. Everyone agrees on a contract, which is your model or your classes or whatever you're using. And for me, this is kind of like this, you know, stable castle. It's like a nice fortress. Nobody can get in, only through the door right there. So you can get in server data in or library interaction in and out. And actually, we're in Alicante, so just imagine this is like the little castle in Alicante here. I need to go there today, because otherwise I don't have any time. But just think about this mental model. This is your application, this is our fortress. So now we have a partly typed architecture, to be honest, because we have our architecture, which, like our castle, which is in the business logic, well typed. There cannot be any runtime errors, theoretically. But of course we need to talk to the outside. It's like with Haskell. Like how can a program be useful if you don't compute any values from the outside, right? This is like this running joke in the Haskell community, and that's true. You need input data to calculate something to get output data, and if it's a website, you want to generate a website, of course. So we need to communicate with the server or with libraries, and the user interaction as well, like if someone clicks and stuff like that. So let's start with the server communication. How can we do this? So we have our REST endpoint, for instance, which vendors JSON data. That's like, I think we can all agree that JSON is quite well suited for that. And what we need is some kind of validation process, which says, okay, are you in the right shape to be allowed to get into my castle? And if it's well typed, if it agrees and it doesn't throw any errors, it is let into the fortress, and hopefully it's not a Trojan horse or something. So that's very important. So how do we do this validator procedure? Because it's very tedious. This is also another thing a lot of people are complaining about. There needs to be, that's the point for Java. Like, there is a lot of tools how you generate model types and validators and all this stuff. This is already there. And there are some things which you can use for Flow. There is, for instance, the project called Flow Runtime, which takes your type information and which is able to take the type and pull it into the JavaScript space while adding validation attributions to it. You can add like a validation procedure for an email attribute and stuff like this. And it uses a Babel plugin for doing that. And if you're more on the lightweight side, I can also recommend the library validated, which is kind of like JSON schema, but a little bit less verbose, so you can write it very easily, and it has flow support. Or, the non-plus ultra, use GraphQL. If you have GraphQL, just think about it. You have a schema. So by default, you have a valid contract which has the tools to generate the flow typings out of that, and you can use them in your little fortress to define your business logic. And then you don't even have to validate it, because it's validated by nature. The contract needs to be intact, so you know that data has this right shape. Cool. So now we have a well-typed server communication. Let's think about third-party libraries. This is like my major contribution to the whole Flow ecosystem. I was talking a lot about it. I was trying to make people aware of it. So we have things which are called library definitions. And library definitions are kind of like a mapping. So you know that from TypeScript there's a definition file. It's kind of like the same thing. But Flow needs a different syntax. This is not JavaScript, this is Flow-specific code. So this is something you need to extract into your own file. There is a folder by default which is called flowtyped/npm/ and your library name. If you're getting it from flowtyped, I will explain this a little bit later. But the idea is you have a syntax called like declare module Lodash. So if you require Lodash in your project, it will automatically use these definitions and skip all the flow typings which are maybe present in the Lodash library. And maybe you have a good eye and you see I use any there. I was a little bit lazy. I just wanted to give you an idea. Don't use any if you can. So very important. So this module would, for instance, export an object which has a map attribute, a map function with this callback definition, or with this function definition. And of course, there are common libraries. There are very famous libraries, like Redux Form, for instance. So there is a project called flowtyped, which is a repository on GitHub, which provides you with a CLI so you can download and automate the installation process of all your package.json dependencies. How does the publishing process for a maintainer look like? So if a maintainer has a library, they need to create some kind of library definitions, because you have to track your library definitions by Flow version, because sometimes Flow introduces breaking changes because they refine the type inference or they refine the type checking mechanism. So sometimes the library definition will break. So you need to think about that. Flowtyped has mechanics where you can track your library definitions by Flow version as well. You can also define a Flow range, like the version range. So you need to separately publish them to npm and flowtyped, and if you're a user, you npm install your package or yarn install it, and with flowtyped you install the library dependencies. Sounds very tedious, but if you have been working a little bit with it, I find it very convenient to work with, and it's worth for me to use Flow for the type inference. So now we have a fully typed architecture. I didn't talk about the user interaction because the user interaction is usually handled by your view library, for instance, React. So React is usually already well typing the user interaction if I'm having a mouse click or if I'm having a key down press or something. So this is also very nicely handled. And by theory, if the validator procedures are in place, if the library definitions are correct, your application is like to 90% sure not to crash during runtime. And that is a huge deal when you think about what I was talking about React Native. I don't want the main thread to crash. That's my most important issue. I don't want any iOS and Android developer mocking me that I'm a JavaScript developer. That's very important for me. So I like this theory, and I would like to go there. I would like to have a fully typed architecture always. So how can I improve? Because this was a little bit tedious. You heard a lot about concepts, and it's like kind of funky. I realized TypeScript has a huge advantage because they have, I mean, it's not only a syntax extension, they have specific features which are not present in JavaScript yet, like module namespaces, or namespaces inside a module, or I don't know, like there are some structures which are not there. They also have a better infrastructure for the library definitions. So I think that compiled.js is not such a bad idea. I would like to be more functional. I like this functional composition. I would like to have first-level support for that. I want to have a pipe operator, which is already in the making for the TC39. I'm not sure how this will turn out, but we will see. I want the perfect type siftiness with strong tooling. And now everything kind of... Huh, interesting. Okay, so strong tooling. And a lot of people would say, yeah, well, why don't you use Elm or PureScript? That's right, that's a good language. It's strongly typed, it's like pure. Why don't you use that? So my major problem is familiar syntax. So a lot of people are really, really afraid of functional code. I don't know, it's also for me it was kind of hard to get into Elm, for instance. If you've never seen Elm code, you should really, really check it out. You can learn so much from it, and a lot of libraries are inspired by the Elm architecture. And I want to have easy interoperability. And in Elm, for instance, it's kind of tedious because you need to create kind of like a channel, a funnel between the Elm space and the JavaScript space. And sometimes you cannot really reflect specific JavaScript APIs because they are sometimes very dynamic, sometimes class-oriented, and it's very hard to map them to the Elm space. So these are not options for me. And you already got spoiled. What do you think is like my holy grail right now, and it's like coming from the top? It's Reason. And I just want to know who of you have been using Reason or heard about REASONML? Wow, that's quite a lot of people. And I guess a lot of people were already like afraid of the first example, like, oh, this probably takes a while to get into. I will do it later. I just put it in my like bookmarking, and I did it as well, by the way. So REASONML. What is REASONML? As you can see, it's like a puzzle piece in this huge concept. REASONML is just a syntax extension to the OCaml syntax compiler. So what is OCaml? Does anyone know? It's a very, very interesting language. It has been around for 20 years now, and it's like 1 year later after Java or something. So I guess maybe if they would have been faster 1 or 2 years, maybe we would all be OCaml developers by now. But yeah, I don't know. OCaml, like the O stands for objective, so it's a ML-based functional language which has also capabilities of doing object orientation. And the cool thing about it is it does object orientation really, really well. You can have imperative control structures like for loops, while loops, and all the stuff you need. You can do side effects inside your functions. So this is kind of nice. This is always the thing everyone complains about Haskell, because you need to know the IO monad and stuff like this. Okay, but this is OCaml. And on top of OCaml, there's the compiler, there's the package manager, which is called OPAM, which works a little bit differently to NPM. And there's Merlin, which is your little helper to do the auto-completion and the editor support. So it's kind of like the flow process which is running in the background, giving you type inference information. And Reason is not only the syntax, but what they try to do, the whole project tries to unify the JavaScript community with the OCaml community. And this is a huge deal, because one thing I really love about the JavaScript community is they want to have nice documentation. They are really into design. They are really into making it a community effort, bringing out the word. They're really good at communicating their concepts. And with OCaml, it's kind of like, oh, you have like kind of a README file of 1990, which is intimidating in the beginning, but after you get used to it, there is tooling around it to make it nicer and to convert it to Reason and everything. So they just try to connect these two. And also, since OCaml is semantically very similar to JavaScript, it can be compiled to JavaScript very easily. And you can do very nice interoperability, which I will show you later. And also they want to integrate the NPM ecosystem in there so that you don't really have to interface with the OCaml, OPAM packager, manager, or whatever. You just use NPM for everything. Okay, so how does the tooling look like? There's a tool called BUCKLESCRIPT. And BUCKLESCRIPT is a tool developed by Bloomberg. And it takes Reason and ML files. ML is the OCaml format. It takes both of them. You can have a code base consisting of everything of this. And it emits JavaScript files. And it's kind of interesting if you look at the output, it kind of translates really, really well into the JavaScript space. And you get this whole environment, very similar like TypeScript with an npm install -g bs -platform. And just think about like all the tools you need for JavaScript if you want to do a proper project. And that's what we did with our microservices, and it got really, really hard to maintain. So we need, first of all, we need flow for static type checking. We need be able to strip out the flow type information. We need Webpack to make a bundle out of it. We need ESLint to enforce specific style. We need Prettier to make it like look like something. I don't know. And then we have, if you want to have function programming concepts, we also need Lodash with the function interface, or Ram.js, what I was been using. Or if you want to have real immutability, you need to use something like Immutable.js. So it's a lot of stuff we need to take care of. And if you have like Reason tooling, it's basically stripping away all of this. You have one major tool, which is BUCKLESCRIPT. You have the OCaml compiler for the type safetiness. You have the syntax of OCaml. You have also the dead code elimination built into BUCKLESCRIPT. And in the end, you also get another tool, which is called Reformat. And it's also vendored with Reason, which is kind of like the inspiration of Prettier.js, which was kind of inspired by Go format, which was kind of inspired by Haskell format, which was kind of like there's, you know, everyone is cross-learning across the ecosystem, which is really nice. And Reformat also just takes the code, makes an AST out of it, takes the comments, and reformats it in a very, very pleasant way. And you don't, like, this is the nicest thing, you don't have to bike chat about syntax anymore from the very scratch, before you even use the language. That's nice. It's really, really nice. And Go has proven that this is a really, really good way to do it. Okay, so this was like talking about it, but how do we do this like fully typed architecture now? And if you know my talks about Reason, I usually talk about tic-tac-toe because I think it's a very familiar concept. Everyone knows tic-tac-toe. You have 9 boxes and you have an X and a circle. And let's design this, right? So what did I tell you about like application? We start with the model. And maybe to make it a little bit more familiar to you, we start with a flow example. So let's define the model types. First of all, we have a token, type token, which is a string literal, which is either XO or empty, because it can also be empty, right? Then we have a board, which is an array of tokens. And here it's just a whatever size. We need to calculate the rows and the columns out of it, but, well, it's a good model for the beginning. Then we have a player, which is also X or O as a string literal. And then we have this kind of scary structure, which is an intersection type. It's an intersection object type. So you have different objects which have a shared format. So here they share the type attribute. And you have seen this probably with Redux actions. They also have a type attribute. And here we have 3 like types: turn, win, or draw. If the game is in a state of turn, we have a player who is going to put their token. If it's going to be in win, this player is won, we render the win, success screen, whatever. And if it's type draw, nobody has won, we don't have to display anything, just show the user that it's a draw. And then we have a state for our tic-tac-toe component, for instance, which is a board and progress. That's easy. So no nullables in there, everything is well typed. So let's see this in action. Just imagine we instantiate a progress object. So we say, I just add this annotation so we can make sure that the type checker realizes this is this type. So we have a progress object which has type turn and player X. And this is okay, this will type check. And then we use a switch, which we always find in a reducer function also. And here, why is this game? This should be progress. The type checker would have found this error, by the way. So progress.type, if it's turn, we can deconstruct a player attribute from this game variable and just return a string or something like this is this player's turn. And the same we can do with win. And then we can say player has won. And the nice thing about it is Flow is clever enough, and TypeScript, I guess, also, is clever enough to realize if this is in case turn, it has to be an object with a player attribute. If you try to do this in draw, it will complain that there is no such kind of player which is a string. This is not existing. So let's talk a little bit about this pattern matching thing. So this is kind of like pattern matching. You have like intersections, and inside these intersections you try to deconstruct your object. There are some major issues in there which I find really, really unpleasant. First of all, switch is not an expression. That means there is no return value out of this expression. I cannot assign it to a variable. This is kind of a bummer if you're a functional programmer. Second of all, progress is always type of object. We need to use objects during the runtime just to have this nice convenient switch, which I find a little bit overkill. Yeah, the flow infer can be brittle. It's not perfect. Of course, you can have intersections where you have same attribute names with a different type, and then you're using the wrong type, and you get error messages which are very confusing. And another one, did you see this actually? Winner? There's a typo. The case is called win, not winner. So when I use this, I'm kind of forced to use constants, which is also during runtime. I need to ship that. That's insane. And then we have no checks for exhaustiveness. Flow would not tell us that there is no draw case. So this is also very bad for me. So we have potential error cases here. Oh, it's also verbose syntax, because we can have, if you miss a break or if you miss a return statement, it can fall through, which is also very, very history. I think it's like legacy, like C and whatever. We cannot do anything about that. But we can use ESLint, of course, yeah. All right, so let's design this. Now forget everything, everything you've seen. Just think about Reason. Now we design this whole thing. Now we design the models in Reason. First of all, the type names are lowercase. This is a convention by OCaml. OCaml will complain if you make it uppercase. We have a token which is either X or O or empty. And you don't see any like ticks here because these are not strings. These are not values. These are actually types, which are called tags. And these will be compiled away if they are simple as that. I should probably learn how to use this. Yeah. Then we have a type row. And the parentheses tell us it's a tuple. A tuple is a fixed size data structure. So it needs to consist of 3 tokens. If I try to instantiate a row which has 2 tokens, OCaml will complain, or Reason will complain. So we now have a row type. Then we have a board type which consists of 3 rows. So we automatically eliminate the problem that with an array we need to calculate all the rows and the columns. We just say it verbosely. You cannot have more than 3. You cannot have more than 3 rows or whatever. We have our player, which is X and O again. And maybe you get confused by the pipe over there. This is just convenience. If you add another type or if you rearrange the code, it will not break the syntax because it's composed. Then we have our progress, and this is the most amazing feature and most important feature. These are tagged unions. That means we can define our type turn, win, and draw, and we can add a payload the same way as Redux does it with their actions. We can define progress as a turn action with a certain player structure, which could be X or O or empty. And then we have our tic-tac-toe state, which is abort and progress, the same as in flow. All right. Make sure to make a picture. Very good. So let's model types in action with reason now. And this is, I love it. It's just my favorite feature. First of all, this is so nice. You just write let progress equals turn X. And that's what I wanted to show actually with my initial talk idea. I wanted to show how the editor will infer the type. Reason will automatically know that progress is of type progress, just because it knows turn X is a player, turn is like a progress, so it knows it's a progress. So I don't have to annotate it. And the switch is a syntax sugar of reason. It actually decomposes into a match statement in OCaml. And this is just a way how they want to make it more familiar to the JavaScript developers. So what we have here is a pattern match structure. First of all, this is an expression. So it will return one of those cases, which is a string. It will automatically infer that. So this can be assigned to a variable. Second of all, we have the pipes here, which is just a case. Then we say if it's the case turn, we can deconstruct the payload player, and then we just use a typecast to a string, which is necessary in a static type system like this, and that's it. If we try to return a number here, then this will not work, because what you need to do is all these cases need to return one unified data structure. If it's a string, if it's an integer, if it's a float, whatever. And here, we made a draw statement, because it has an exhaustive pattern matching. If we would leave out this case, OCaml would emit a warning, not even an error, just a warning that this might be not what you want. Maybe you want the case draw, and it will automatically tell you, it's draw what you're missing. You can also have a default case if you don't care about it. But this is just very, very lean syntax. It's fully typed, and it's also an expression. That's the most important thing for me. Just a little comparison. This is the JavaScript code. Again, a lot of things you can do wrong, and a lot of things I did already wrong, especially if you use Redux with immutable data structure, which is the spread operator, which is not immutable data structures per se. I mean, they are kind of immutable, but it's a lot of like extra effort to generate objects over and over again. How would a validator look like? So this is probably one of the major problems people have when they try to use a static language like this. So what we have to do is kind of like use a function provided by BUCKLESCRIPT, which is called parse, which can also throw an exception. So OCaml is also able to throw exceptions. As I said, it's also an object-oriented language. And we can parse this text, what we get in there, which is supposedly a string, and pipe it into a function. And you can see that OCaml is a lot of fun because we use fun a lot. So it's kind of, we get this function exposes us a JSON data structure. And then we have this kind of weird thing which is called decode. So we can put it into shape like a cookie cutter. And then we have an array of string, like the board, because it's like X and O, because we cannot communicate in types, because JSON doesn't have like a definition for that. So we need to parse that explicitly. So we get this data structure back there, which is an object of shape, board, and progress, and convert the data with another function. And the convert data is something like, okay, we have a function convert data, which gets an object with a board and progress attribute. This is typed flow. Now I'm talking about flow. Reason will notice that board is of type board and progress is of type progress, just by the way how you use the function. And here we are explicit with, so you can see how a return type is being defined. This is the return type of tic-tac-toe state. So this function needs to return a tic-tac-toe state. And luckily enough, this is actually returning an object with board and progress, so this should be well typed. The only thing I left out is the pass board and the pass progress, because it's just basically, are you an X, are you an O, are you not an X and O, draw an error, something like this. How about the server? How do we do like fetch? Because fetch is kind of like very essential if you want to communicate with your server. So there is this thing called gs.promise. It's also built into BUCKLESCRIPT. And there's also BUCKLESCRIPT bindings, which are kind of the library definitions for reason. And what I'm using here is bsFetch, and it exposes a function which is called fetch. You can just add what you're trying to fetch, and then you can pipe this to the then function. The underscore is necessary because then is a reserved keyword in OCaml and in Reason, so they needed to like differentiate it. And also this kind of thing looks a little bit weird. This is kind of a local module opening. So just for this scope, we're getting all the functions which are exposed by the promise module. Wow. Wow, this thing is not working at all. Sorry. I think it's also too excited about this technology. That's what I think. Okay, so again, we don't use any type information here because Reason is already capable of doing that. And here is just so you can relate to it. This is how we would use it in Flow. We just expose return type promise tic-tac-toe state. That's it. So, does this? All right. Now we go to the components, because this is also one of the most exciting features. Reason has first level support for JSX and for React. And Facebook is using Reason like to 50% in the Facebook Messenger app. So if you have been using the Facebook Messenger app on the web, you probably have been using a Reason application as well. And they just have a different mentality how you instantiate or define a component. And the great thing about it is that you don't need Redux. You don't really need Redux because the ideas of Redux are already built into the language, and you can leverage this inside of the component. So what they defined is they don't have any stateful components. So what they have is a so-called reducer component. So they try to lean on the reduce concept of Redux. And we just give it a name tic-tac-toe. We get out an object of type component of this tic-tac-toe component. And then every file like this, tic-tac-toe.re, is a module by default. You don't need to import anything. You don't need to do anything fancy. BUCKLESCRIPT will automatically detect it and compile it really, really fast. And then we need just to define in this one file, we define a make function which gets our props, which can be named. So we have a board prop, which can be which doesn't need to be defined. We have a progress, and we can also have children, which are also really well typed. The underscore in children just means we don't use children, just ignore it for the compile process. Reason does also a very good job in telling you if you're not using a variable, so you don't even need a linter for that. And then we just create a new object out of it, spreading in the component, have an initial state function, and then we have this reducer function. A reducer function gets an action, the current state, as we define it here, which is tic-tac-toe state, and then we just have one pattern match on the action we want to expose. So we have this here again, a tagged union, play turn with a selection, which is an X and Y coordinate, or a row and column, and a restart just to reset the game. And that's all we need to do. And then there's this nice feature that you have to return a new type, similar to this, which is like reason react.update, and you can have something like no update, and you can have update with side effects. You can explicitly tell the component how to behave for the rendering. And this is huge for React 16, I presume, because also in the documentation there's a lot of React 16 nomenclature in there. So this is really nice. The render function is practically the same. We get an object with state and reduce. The reduce is just used to call an action, and that's it. just look at the reduce, like in the, this is the render function, for instance, and you see it's very similar, it's just GSX, and we can also use the pattern matching switch here because it returns us a GSX element and stuff like this. So I really, really enjoyed GSX in Reason because it's also well typed, and also the children's can be typed easily. Okay, and I'm rushing through it, it's already very late. So the library definitions are kind of the hardest part of it to understand. It's very much easier to understand if you know a little bit of OCaml. But in general, there is kind of like a Reason community with BUCKLESCRIPT bindings, which you can just retrieve through npm. You install it, you just tell BUCKLESCRIPT to use this binding, and that's it. User interaction is also handled by the Reason React binding, so there is nothing to do there anyways. You just have this handle click function which gets a mouse event and returns unit. Unit is kind of the null value of Reason. There is no null in Reason by default, which is great. And yeah, and just for the sake of it, because it's a tic-tac-toe game, there is no real server interaction, but I made a project which is located in the Reason London repository of mine. It's an example of a tic-tac-toe web application written in Reason and a tic-tac-toe server, like tic-tac-toe as a service kind of thing, written in OCaml. And you can see how the project setup is being made and how the initial request looks like and how I handle error promises and stuff like this. So, recap. First of all, for me, most important, if I write JavaScript, I use Flow because I like the type inference system, very similar to the OCaml one. If I have any chance to write anything new, like if I have the choice, I would use Reason for that, or OCaml, because you can also compile server applications as a native executable. I try to design my applications as a strongly typed architecture. I try to get the library definitions right. I try to motivate other people to use a type system, because if you're using a type system, you're designing your library in a way that can be typed. That's super important for me. And of course, validators, so you don't mess up your application because of a whatever undefined error. All right, so this was very long, so thanks for watching. And I'm open for questions. Yes. There's one over there.
Hello. I have many questions, but I can narrow them down to 3 maybe. For imports, you sort of glossed over there in this third to last slide. Is it easy to import stuff from npm into your Reason code? Or does it not come from npm, or do you have to come from some other Reason package library, or what?
No, so Reason tries to use npm wherever possible, or yarn. So you just install, for instance, bs-fetch, bs-fetch, and it automatically polyfills the things, like the JavaScript stuff, which needs to be emitted. Or what do you mean?
So does your Reason project have a package JSON, or is there some other thing?
There is a configuration file for BUCKLESCRIPT, just a JSON file.
Okay, question number 2. How is it feasible to write a library in Reason that can be published to npm to be consumed by JavaScript?
You mean?
Presumably there's some sort of build process that converts this into JavaScript.
The same way as with Babel. So if you transpile with Babel, it's the same with Reason. You transpile it to JavaScript and have a lib folder in there, or you publish it to npm.
Okay.
Yeah.
Okay. Last question. So this feels a lot like what happened with CoffeeScript, where this was a beautiful, elegant syntax that everyone liked because it was better than what was the standard, and then eventually the standards caught up and everyone forgot about it. How is this different?
Well, OCaml is like the fundamentals of the type system are just much more like thought out. And I mean, there is a type system. OCaml has been around for quite a while. for me, it's like I have a very, very strong type system which helps me doing stuff and refactoring stuff. In CoffeeScript, it's kind of like it's still dynamic.
But you're still ultimately transpiling down to JavaScript. Always.
For sure.
Okay.
Of course, yes.
Just like CoffeeScript was. So.
Totally.
Okay. So you think there's some future here that is not going to suffer the same fate as CoffeeScript?
Well, I don't know.
Maybe. Okay.
I mean,
We'll
Reason.
see.
I mean, Reason will also
We'll come
inspire
back in 5 years
different paradigms. I mean, already like the reducer component got traction in the React community. We're like, oh, that's a really great idea. And for me, it doesn't really matter. Like, I mean, of course, there's always a risk of having technical debt through another language. But for me, it's like a language which has been around for 20 years is not going to go away. And CoffeeScript is kind of like very young. And I don't know. I cannot really evaluate that, to be honest. There was another question over there. Yeah.
So you've mentioned that we don't need a Redux anymore, and you've showed that you can use a reducer component.
Mm-hmm.
But how can you map state to props to another components from the one that you create a reducer in local? So basically, I want to use props in the 10th component related to that one. How can I consume state from?
I mean, what you can still do is like you usually have one parent component, where you put down like it's very similar to the Elm approach, where you also have the thing where you always use the children to pass down the props. I know what you mean, like intermediate connects, right?
Yeah.
So, I mean, there are probably ways to just have one global store, because this is possible in Reason as well, and just use the language for the connecting of the data, because you don't need to like the. Okay, I cannot really answer this question like this in the instant, but for me it doesn't sound like a real issue for the use case I would use it.
So basically, it sounds like we have a React state in the component, and then we move to the Redux in order to get all the state and map state to props, and then now we have also the reason that's going back to the beginning, where React already have the just inline local state.
Yeah.
If you want to share a state, okay, move it to the parent component.
Yes.
Okay.
What about tests?
You can use.
Can we still write tests for applications?
Sure. There is BUCKLESCRIPT bindings for chest, so you can just use chest.
With all like features, snapshots, everything will just work.
Yes.
Cool.
More questions? No? Thank you, Patrick.
Thank you.